Hello, this is my problem for the Canadian Computing Contest Senior Problem Number 1, summarizing a sprinter speed. So we'll read the problem description. Tricky Dingo is trying as usual to catch his nemesis, the street sprinter. His past attempts using magnets, traps, and explosives have failed miserably. So he's catching his breath to hold and gather observational data and learn about how fast street sprinter is. Tricky Dingo and Street Sprinter both inhabit a straight line going west to east with a particularly famous rock on it known affectionately as the origin. Positions on this straight road are measured numerically according to the distance from the origin, using negative numbers for positions west of the origin and positive numbers for positions east of the origin. Observations of Tricky Dingo each contain two numbers, the time and the value of a street sprinter's position at the road at the time. Given this information, what speed must street sprinter must be capable of? So we'll look at the input specification. The first line contains n. Number of observations are followed. The next n lines contain an integer that is equal to or greater than 0, but less than or equal to a million, indicating the time in seconds of the measurement when the measurement was made, and an integer that is equal to or bigger than negative 1 million, and but bigger than or equal to 1 million, indicating the position in meters of the street sprinter at that time. No two lines will have the same value of t. For 7 of the 15 marks, n will be less than 1000. So, else with specification, output a single number x such that we can conclude that a street sprinter was at least x meters per second at the time at some time and point such that x is the largest possible. So already what the problem is just axing is to find the minimum amount of speed needed to catch up with the street sprinter. So look at one of the test cases here. Explanation over here. Since the street sprinter ran from position 100 to 120 between time 0 and 10, we know its speed must have been at least 2 at some point in time. If it was always less than 2, then a distance of 20 could not be covered in 10 seconds. Likewise, speed must have been at least 7 in order to travel between the position 120 and 50 in 10 seconds. Alright, so I already have an idea. Idea would be because we need to measure the time from one position to another position. We need to put this. We need to sort this based on the time, and after that, we would divide the distance from time one. You take the difference between the absolute value of time one and time two, and divide that by the absolute um, absolute time from the difference of time one and time two. So yeah, I'll just start the coding now. So first things first, I want to get n, so I know how many test cases I'm going to get in. So input, I'm going to iterate that many times, and then I'm going to throw it in a list for positions. For I in the range of n, we'll do positions, or I'll do this. Um, yeah, I'm gonna store it in a tuple for I'm gonna store it in a tuple because it's just two. It was gonna be two variables coming in: the time and then the position. So I'll remind myself here. And position is coming in. So we'll just do it here. The result went to the tuple version of mapping it. Mapping whatever comes, the input that comes in. I'm gonna split it and map it to its integer version. And I'm gonna convert that to a tuple. So okay, I'm gonna do position. I'm gonna add the result, append it to the end of the list. Okay, and since we know necessarily that the position and time that comes in is not always going to be ordered, we have to sort it ourselves and after that. So yeah, I'm gonna sort positions, the sort positions based on the lambda function, the function where we look at where the tuple comes in. So T stands for tuple. It comes in, and then we map it to its so time. We map it to its time. So we map it to its first value. All right. So then we'll just gonna print list. Make sure we're doing this right. Sure we're okay. Run test case here. Type in 3, 0, 100, 50, 10. 10 and 120. Oh, sorry, 10 and 120. Yeah, you can see here I sorted it based off its first value at the time. Okay, now that I have it sorted, I'm going to declare another variable, the minimum speed, and I'm going to set that to -1. So I'll go over, and I'm going to do so I'm going to do a method called prefix array, where we start and then we compare the value to the value of the item to the one before it. So yeah, I'm just gonna go here, go start here, go here. So over here it tells us we have a time of 10 seconds. Okay, go over here, We have a difference of 20 meters. So then 10 divided, or sorry, 10 divided by 20 divided by 10 would give us, we need a minimum of 2 meters per second, minimum speed. So yeah, so I'll do for I in the range of 1 to the length of positions, and the range of length 2 positions. 1 second. Alright, back, sorry. For I in the range of the length of the positions. Yeah, and then we'll start here, and then we'll just compare it to the value before it. So get our distance 1. We'll set that here. Or you can get our distance. So yeah, our distance will be this. It's going to be positions I minus 1 to compare the value before, minus positions I. So yeah, just comparing the one before it and the one current, taking the difference of that. We'll do, we have to index, because we're in a tuple. We have to index again, because we're in a tuple. Sorry. The time here is equivalent to positions I minus 1, 0, minus positions I, 0. Okay. Now we can get the speed, because now we have the distance over time. Speed is equivalent to the absolute value of the distance divided by the time. Okay, here. I'm gonna come here, then we're gonna go here. We're gonna do our conditional here. So if the current speed is bigger than the minimum speed needed, then we're going to reassign the value of the minimum speed. So we'll do here a simple compare operator and minimum speed, and we'll do speed equivalent to speed. And I'm just gonna print minimum speed at the end to solve the problem. So I'm gonna run a test case 3 incoming. So at position 0 we had at time 0 you got position 100. Time 20 you're at position 50. At time 10 you're at position 120. As you can see, it outputs 7. You need a minimum speed of 7 to complete, or you need a minimum speed of 7 for to catch up to the nemesis. I'm gonna do another test case. Then run it again, so do 5. Oops. Run all the test cases here. And I should get 6.8. Back up the program. and I get 6.8 back at the program. So yeah, um, I'm going to submit that online. I'm going to submit this to the grader. Sorry. All right, so I've downloaded the file over here, the one we just created the solution for. I'm going to go over here to the contest submission. I've already solved it, but I'm just going to show you guys. Sorry. I'm going to go to the bottom here and input summarizing a sprinter's speed. Do Python 3 for my language. Then I want to choose my file. So I just speed. 1 second. So yeah, I'm back. Sorry, I keep on cutting out. I'm sorry for you guys. So now I'm just gonna submit it. I'm gonna pick summarize printer speed, the Python file over here. I'm gonna submit. And now at this point, the grader is compiling and checking against test cases. And I'll just wait for 10 seconds for the result of the code. And now I'm going to reload the page to see what I graded. And it's still grading halfway there. Sorry, I keep on cutting out. That's my fault. All right, so we resume back to the place where it was done. I was marking half of the positions. I'm gonna reload the page one more time, and as you can see, we got 15 out of 15 points. So it's passed all test cases in the time limit. So that is just right here. This is the solution for Canadian Computing Competition Senior Problem Number 1, summarizing a sprinter's speed. Yeah. So and then we could say, let's say at the time complexity, my bad, time complexity is going to be o big O of n log n because I'm sorting it, and we're going to do space complexity space complexity is equivalent to big O of n because I input every position into my positions array, and that is the size of however many n is coming in. So that is the solution for summarizing speed of the 2020 senior problems.